Today's lesson is going to be on estimating surds. And one of your first questions might be, what is a surd? When we take the root, the nth root of a number, and the result is an irrational number, that is an example of a surd. So let's say we take the square root of 2. The square root of 2, if you put that into your calculator, you should get 1.4142135, and this is just going to go on and on and on indefinitely and never terminates. And this is an example of an irrational number. If you need a refresher on the difference between rational and irrational numbers, you can refer back a couple videos to where I explain in detail the difference between rational and irrational numbers and where these fall in the real number system. So let's look at an example like the square root of 4. The square root of 4, if you put that into your calculator, you're going to get 2. 2, we know, is a rational number, and so this is not an example of a surd. Now in grade 10, you are going to be expected to know how to estimate surds, and by estimating surds, I mean you're going to have to be able to tell where a certain surd falls on the number line. So let's go back to our example of the square root of 2. The square root of 2, if we put that into our calculator, we can round this off to 1.41. Now we know that on the number line, let's say we have a number line, and I haven't drawn this to scale as you can see, but we know 1.41 is going to lie about here, between 1 and 2. Now let's say we took the square root of 3. If you put the square root of 3 into your calculator and you round that number off, you should get something around 1.7. So again, that's going to fall between 1 and 2, closer to the 2 side. So let's say we didn't have a calculator. How would we know that the square root of 2 and the square root of 3 fall between 1 and 2 on the number line? So the way that we can tackle that is, let's try and find a perfect square that we know the square root of, and we can use that to be able to estimate. So let's say we take the square root of 1. We know that the square root of 1 is 1. We know that our next perfect square is going to be 4. The square root of 4 is equal to 2. So by using this logic, the square root of any number that falls between 1 and 4 is going to result in a number that falls between 1 and 2. That's why the square root of 2 falls between 1 and 2, and the square root of 3 falls between 1 and 2 as well. So one of the most important things to remember when estimating a surd, let's say we have the nth root of a. And let's also say that a is less than b. What we know is that if a is less than b, then the nth root of a is going to be less than the nth root of b. So using this logic, what this essentially says is that if 2 is less than 3, then the nth root of 2 is going to be less than the nth root of 3. So using another example, this says that the square root of 1 is going to be less than the square root of 4 because 1 is less than 4. And we know this to be true because the square root of 1 is 1 and the square root of 4 is equal to 2. So this is essentially going to be what we're going to use to estimate any surd that we come across. In grade 10, you are going to need to be familiar with both the squared roots and cubed roots. So let's just take a second to introduce you to the idea of perfect squares and perfect cubes. A perfect square is the result of a number squared. That seems kind of simple, but that's actually exactly what it is. So 4 is a perfect square because when you square 2, you get 4. When you square 3, you get 9. So 9 is a perfect square. When you square 4, you get 16. When you square 5, you get 25. So all of these numbers are perfect squares. Let's talk about some perfect cubes. 1 is also a perfect cube. Let's say we take 2 cubed. 2 cubed is going to be 8 because 2 times 2 times 2 is 8. 3 cubed is going to be equal to 27. 4 cubed is going to be equal to 64. And 5 cubed is equal to 125. These are all perfect cubes. So I'm going to take a second to write out all of the perfect squares and all of the perfect cubes. Here are all of our numbers from 1 to 13 squared on the left-hand side, and the numbers from 1 to 13 cubed on the right-hand side. So if we were to take the square root of any of these numbers on the right-hand side, we would end up with this number, just without the square. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Square root of 49 is 7. And you'll find if you square root any of these numbers here, you're going to get this number on the left-hand side. And here, you can take the cubed root of any of these numbers here, and you should get the number on the left. So the cubed root of 8 is 2. The cubed root of 1 is 1. The cubed root of 27 is 3. The cubed root of 64 is 4. The cubed root of 125 is 5. And so on. You can do this for all of the numbers, and you'll find that the cubed root of any of these numbers on the right-hand side of the equation is going to give you the number on the left side of the equation, just without the cubed sign. So those are your perfect squares and your perfect cubes. For example, now let's try to estimate this surd here. Let's try to estimate the square root of 5. Now, try and pause this video and see how you can determine what the square root of 5 is and between what two numbers in the number line the square root of 5 might lie. Okay, so how might we tackle this problem, the square root of 5? Now, let's say we've memorized all of these perfect squares and perfect cubes. So what we can recognize is that the square root of 4 is 2. That's something that we know. And the square root of what's something higher than 5, that's a perfect square. We know that 9 is higher than 5 and is a perfect square. We know the square root of 9 is equal to 3. Okay, so the square root of 5 is going to fall somewhere between the square root of 4 and the square root of 9, because 5 is between 4 and 9. So the square root of 5 is going to lie between 2 and 3. Another way that we can just write that out to make it a lot more clear, let's say the square root of 7. What we can do here is we need to find a number that's a perfect square that's less than 7 first. So we can use 4. Then we need a perfect square that's greater than 7, so we can use 9. And we know that the square root of 4 is equal to 2. We still don't know exactly what the square root of 7 is without a calculator. And the square root of 9 is equal to 3. So we know that this number, the square root of 7, is going to fall between 2 and between 3. And let's actually take a second and plug that into our calculator to confirm that what we have is correct. if you plug in the square root of 7 into your calculator, you will find that it's equal to 2.64575, and that's going to go on indefinitely. So this is an irrational number, so again, this is a surd, and we can see that 2.64 or 2.65 if we're rounding up is in between 2 and 3. So whenever you are dealing with a surd estimation problem, the way that you can tackle that is to write down your surd, in this case the square root of 7, then you're going to write down a perfect square, or let's say this was asking for the cubed root of 7, then you would write down the perfect cubes that are both below and above your number of interest that you're trying to find the square or cubed root of. And you're going to solve for those perfect squares or perfect cubes because you would have memorized them from your table. And that is how you can find in between which two numbers a surd lies.